Hello viewer, welcome to Samuel Academy. My name is Samuel. In this video, I want to talk about fluid flow. What is a fluid? A fluid is a substance that is capable of flowing. It can be a gas or a liquid. A flowing fluid experiences internal resistance called viscosity. Viscosity is that kind of friction that is experienced in fluids. Let us look at types of fluid flow. We have streamline flow and turbulent flow. Streamline flow is also called steady flow or laminar flow. Let us discuss more about streamline flow. At any given point in the fluid, every particle of the fluid travels in the same direction and with the same velocity. So if you pick any point in the fluid in streamline flow, you find that every particle that is moving through that point moves in the same direction and at the same speed. A streamline refers to the path followed by the particle in a streamline flow. So these are streamlines. And I'm saying that a streamline refers to the path followed by the particle in a streamline flow. Streamlines do not cross each other. Streamlines are closer where the velocity of the fluid is higher. So if somebody asks you to draw streamlines, okay, in streamline flow, and there are places where the speed is higher, then the streamlines will be closer where the speed is higher. All right. Now, we have seen that streamlines are parallel to each other, and the streamline flow is smooth and steady. Let's talk about turbulent flow. The speed and direction of the fluid particles in turbulent flow passing at any point changes with the time. So if you choose any point in turbulent flow, you find that the particles moving at that point, their speed and their direction changes with the time. What causes turbulent flow? Number one, abrupt changes in the cross-sectional area of the tube of flow. Number two, when the speed of fluid flow changes suddenly beyond a critical velocity. There is a velocity that we call critical velocity. We shall talk about that. So when the speed of fluid flow changes suddenly beyond that velocity, it causes turbulent flow. Number three, an obstacle. When an obstacle is placed on the path of the streamlines and it blocks or breaks the streamlines, it causes turbulent flow. Now, what are the characteristics of turbulent flow? Number one, streamlines are not continuous. Like in this case, this is a case of turbulent flow. So you find that the streamlines here, they are not continuous. Like in this case, here they are continuous because this is a streamline flow. But here there is turbulence. So the streamlines are not continuous. Okay. Now number two, we find that particles don't travel in the same direction and have different velocity. That is characteristics of turbulent flow. Now next, let's look at streamlined and non-streamlined bodies. So we have in that diagram, this body is streamlined and this one is not streamlined. So a body is said to be streamlined if it does not affect the distribution of the streamlines behind it. So this body is streamlined because it does not affect the distribution of the streamlines behind it. It is moving forward. The fluid is moving like that. So behind it, the streamlines are not affected. All right. Examples of streamline bodies are cars, jumbo jets, and birds that fly. Bodies which are not streamlined and are moving in fluids, they cause eddies or turbulence in the fluid. So, for example, this is a body which is moving in a fluid. Okay, so it causes eddies. These are eddies or turbulence. Okay, they do cause eddies or turbulence in the fluid because they are not streamlined. But this one here is streamlined, so it does not cause eddies or turbulence. A body is said to be non-streamlined if it causes eddies behind it. We have just seen that. A body is said to be non-streamlined, like this one here, if it causes eddies behind it. So this one causes eddies or turbulence behind it, so it is non-streamlined. Finally, what is critical velocity? Critical velocity is the speed of flow of a fluid beyond which the fluid exhibits turbulent flow. So if a moving fluid exceeds the critical velocity, then it will start showing turbulency. The flow will become turbulent. Okay, that's more about a flow in fluids, that is streamlined flow and turbulent flow. So I hope you have enjoyed this video. So kindly like the video, leave a comment, and subscribe to be able to see more about physics and chemistry and maths.